All right. Hello, everybody. Welcome to the October Rust Gamedev Meetup. So this is an opportunity for people who are working on cool stuff in the Rust Gamedev ecosystem and some adjacent ecosystems to come show off what they've been doing. And so we have two presenters this month, and I'm pretty excited about both of them. Last month we had Capri talking about some embedded like no STD kind of stuff, and then we had someone reach out and say like I could also give a presentation on some pretty cool sort of like embedded development stuff, sort of adjacent to game dev. And so we have that as one of the presentations, as well as a presentation from Puzzled Squid about their game that they're working on called Tonnet. And so super excited to get into it. We should have quite a lot of content for today, but I do want to mention, if you haven't checked out last month's Gamedev Meetup, I've started, well, I'm going to try my best to keep making just these posts that kind of include what's going to be happening or what did happen in each of the meetups. And so if you haven't seen the previous meetup, then you can go to gamedev.rs, and then we have the blog post right up here with all the talks and then links to everything. And so you can go and check it out. I do also want to mention Happy Hacktoberfest. I think for a lot of us working in the Rust ecosystem or the game development ecosystem, we probably interact with or create our own open source projects. And so I think this is probably an exciting time for a lot of people to either have maybe people coming and working on their projects, or to give you an opportunity to go work on other stuff. And so for me, I'm going to be running an event trying to teach students how to do some contributions later in the month. But for myself, I'm looking at some stuff to contribute to that I haven't before, and so we'll see where I get. One space that I've been really spending a lot of time on, and I was hoping to have a video here, but I don't just yet. Or I essentially last year for last Halloween, my friends and I, we put together like this outdoor cool like light show and stuff, and so I wrote the controller on the Raspberry Pi in Rust, and it was a lot of fun. And so we're working on some new stuff this year. And so I've been doing a decent amount of embedded stuff. And so I'm kind of curious if I can hop into that ecosystem a little bit and try to give back a little bit. But with all that being said, I think we could hop into what we have on the schedule for today. And so we'll be back in just a second with Noxim, who will be presenting about some embedded projects they're working on. All right, so we are here with Noxim, and so we took a little bit of a look at Noxim's presentation before, but I'm super excited for it. So Noxim, I'll hand it over to you to get started.
All right, wonderful. Thank you. So yeah, today I'll be talking about embedded. It's probably going to be more about embedded than actual game design, but it is game themed, so hopefully it's still applicable. So I titled my talk games but no video, and that's because when we talk about game dev, we usually assume that it's on a computer or a console or mobile, something that has a screen and has like regular input methods. But there's also other types of games that you can use Rust for, and I made one of those, so let's go through it. I've been sort of making games since I was 11. Haven't released a commercial game. Maybe in another 10 years I'll be able to. I've been writing Rust for over 5 years now, I think 6 or 7 coming up. And about a year ago, I started professionally working as an embedded developer. And I've been doing sort of embedded as a hobby, sort of passively for a couple of years. But now that I'm doing professional stuff, I kind of wanted to learn more about the actual hardware side of things. So I know the software fairly okay, but I don't have any sort of formal education about electronics, just like high school physics class. How does electricity in general work? So I wanted to learn more about that. So I needed a project, and I definitely wanted to keep it very simple. I didn't want to go over my head and have like a 3-year-long project. And also, I very much subscribe to the idea that constraints sort of help you bring out your creativity when designing, especially games. So I wanted to give myself a really tight like hardware side and see what I can make. And for context, I wanted to make something like on the level of complexity of like what you would get from McDonald's as part of your Happy Meal. So like a little game trinket. And that was, if you know a little bit about mobile gaming history, the Game & Watch, which was in a way one of the first mobile gaming devices. It was invented by a guy from Nintendo who saw someone play with a calculator on their commute. And he figured, oh, that's kind of fun. That's like a thing you can do for 3 minutes when you wait for your bus. So I wanted to make one of those things that you can just pull out, play with for like 2-3 minutes and be done. So when developing embedded stuff, really the core of your system is going to be the microcontroller. Microcontroller is like your processor and sort of your motherboard and I/O in one small thing, one single chip. And you really have tons of choices where you go with this. There's really popular microcontroller brands. You got ESP32s, STM32s, at Mega, which is used in the Arduino, for example. And just tons. There's like 101 manufacturers, and all of them have 101 different product lines. So there's a lot of options. I wanted something small. So, for example, ESP32 was kind of out. It has hundreds of kilobytes of memory, and it can do Wi-Fi and Bluetooth. So it's kind of overkill for what I needed. And most of these chips also run some variant of the ARM instruction set, which is great because it lets us use common ARM toolchains. Rust supports ARM pretty well. And then some of the smaller, like, for example, the ATtiny, which is a really small chip. It uses a less common instruction set architecture, which makes running Rust a little bit trickier. There are some forks that support ATtiny's, but it's not official support. And there's a sort of new instruction set architecture that came out a couple of years ago called RISC-V. And it's notable because it's free, it's open source. So any manufacturer can sort of implement it, and they don't have to pay any like licensing costs to ARM or anyone else to produce chips that have like wide tool chain support. And one of these chips that got really popular last year is called the WinChip Head CH32V003, which is quite a mouthful, but that's how almost all microcontrollers are. And it got really popular last year in like the maker community because it's really cheap. It's really cheap. You can buy it. It comes in a couple of different packages. So like the chip inside is the same, but they have different form factors. And some of the smaller packages, they go down to under 10 cents a piece, which is really cheap. So I think I picked this chip because it looked cool. It was RISC-V. It was simple. It was really cheap. And in general, it has 2 kilobytes of RAM, which is, if your computer these days has 2 gigabytes of RAM, it's very small. This has 1 million times less, but it's still tons for developing simple games. 16 kilobytes of read-only memory, so that's where your actual program code lives in. And you can get it, depending on the package, you can get it with either 6, I think 12 or 18 like input pins or general purpose input-output pins. It has a bunch of other stuff. It has like serial buses, which let it communicate with other things in your embedded system, like I2C, SPI. It has analog converters, but something that really caught my eye was that it supports power sources that are from 3 volts to 5 volts, which is good because I wanted to run my embedded stuff on these regular like 3-volt coin cell batteries. But also I wanted to have the option to make like a rechargeable lithium polymer battery, which those batteries have voltage of 4.2 volts at maximum. So because this chip supports anything from 3 to 5 volts, I could use any sort of power source I wanted without any external components. So we picked this even longer name, V003 J4M6. The J4M6 just means it's packaged in a SOP 8 package, which is an 8-pin sort of thing. You can see it on the left. And 2 of those pins are used for power and ground, so you only really get 6 general purpose input outputs. Okay, what can we do with those inputs? That's not a lot if you think about it. I mean, a mouse, a regular computer mouse, has way more data you can get from it. Like, of course, you got 2 bits for the main click, but then the movement, that's 8, 16, 32 bits. And like a single pixel on a modern monitor has 24 bits of output. So what can we do with 6 bits of combined input output? We could sort of cheat, and we could use, for example, for the output portion, we could use, for example, displays. I think I have, here's a little OLED display that only needs 4 pins, 2 pins and then 2 pins for power and ground. But you're sort of moving the responsibility elsewhere, so it's not really, it's kind of cheating. It doesn't follow keep it simple. So I only wanted to use simple like LEDs and buttons that map like 1-to-1 pin to input or output. Okay, we can do a little bit of cheating. There's a technique called Charlie plexing, which lets us drive more than n LEDs from n pins. I'll skim over it very quickly, but yeah, this hardware really put those limitations tight on me. How can you make an interesting game that will keep you occupied for at least 5 minutes with just 6 inputs and outputs? Well, because all the inputs and outputs are digital, first thing that came to my mind was something to do with bits. And I started prototyping. I used MacroQuad. It's really helpful. I made my first prototype in like 5 minutes. It's just showing a bit pattern, and then you had a couple of buttons that you could press that would perform like a bit operation on that random bit string. And the goal was to like get all of them to 0 or get all of them to 1. It was okay. It didn't work super well, but after some iteration, I came up with a game that was about having 2 6-bit integers, and then you keep adding them to each other until you get them all to be all ones. And that actually ended up being pretty okay. I liked it. That sort of game requires 2 button inputs, so that uses 2 of our 6 pins, leaves 4 for our LEDs. But Charlie plexing, like I said, it's a technique that lets us sort of exploit the nature of these GPIO pins. So instead of being just pure on-off, like binary, these pins are actually tri-state logic. So what that means, each of these pins on a microcontroller can either output like high voltage or low voltage to control, for example, an LED. If it outputs high, then LED comes on. But you can also set it to an input state where it's called a floating Z, where it basically acts like nothing is connected to that pin. And if you wire up your LEDs in a certain way, you can wire up to like n pins. You can get actually way more controllable LEDs out of it. You can't light them all on at the same time, but if you sort of flicker through them fast enough, you can control quite a bit of LEDs. So with those 4 remaining pins I have, I was able to control 12 LEDs, which is actually perfect because we had 2 6-bit numbers, and 12 LEDs enough to sort of represent that. I also made a simulator of that. It's on the bottom there. Made it in JavaScript. It took me like another 5 minutes, and played around with that. Figured, okay, this is good. So let's make some hardware. Took me a while to learn about how to actually make PCBs. Wasn't the greatest PCB ever made, but it works, which is good enough for me. There's a couple of designs I made for it. The sort of middle one is what what's like the final revision. There was also the bottom one, which wasn't as ergonomic to use. Yeah, and the actual game logic ended up being really simple. So you have these 6 LEDs here at the top and a button next to it, and another 6 and a button on the bottom. Those are your 2 numbers represented by the LEDs. And when you press a button, it adds sort of like the other number to the one you just pressed. And if all of the bits in both of the numbers are on, then you win. And that was really the hardware part of this. I will show you. Here it is in real life. Got these manufactured, took a couple of weeks to ship, but I have one in my hand. This camera, of course, does not focus, but I'll show you a video later on. Looks like this. On the flip side, there's a little Ferris. Now that we have the hardware down, let's get to Rust. So Rust already supports RISC-V, which is great, but RISC-V is sort of a modular architecture. You have what's called a base instruction set, which has very simple things. It has integer addition, branching, a couple of bit operations, and then you add on these like features that allow it to do more things. For example, you can add a floating point unit, and then it becomes an RV32IF, and the F means that it has floating point support. This microcontroller itself, it's an EC part. EC or C means that it has compressed instructions, which helps keep the code size small. But the E is actually a bit tricky because it's not technically part of the RISC-V specification yet, so not all compilers support it. And the E is like a smaller version of the regular instruction set, which only has 16 registers. Normally, RISC-V has 32 registers, but with the E, you only get 16, and it saves a bit of space on the actual hardware die. Okay, Rust doesn't support the E extension because it's not official. It's not ratified yet. It's not a big change. It's only just reducing the number of registers, and with that, sort of tweaking the ABI so it works. Luckily, someone has already done this for us. Some person, I think from a company called T-Head, has made a patch to LLVM that supports the RV32E instruction set. So it was really just a matter of bringing in that patch, applying on top of Rust's version of LLVM, which was quite a painful merge. LLVM moves really fast. I think I was late by like 14,000 commits or something like that. But after a couple of hours of merging, I got it working, and we have proper code generation for our chip. Okay, now what? To sort of get our LEDs and buttons working, we need to do some hardware access. So, of course, because we're writing embedded, there's no STD. You can't just like write out. It's not, Rust doesn't know what it's running on, so it can't include anything out of the box. So we only have core. And to sort of access, for example, how do you set one of the pins on this microcontroller on? You have to do it through something called memory mapped IO, which is just a specific memory address in the 32-bit address space that when you write to it or read from it, that causes actual things to happen in hardware. And there's like thousands of these memory registers, even on these small chips. And they're all documented in what's called a technical reference manual. For this chip, because this chip is very bottom of the barrel, really cheap. It doesn't have many peripherals or hardware functions, but it's still almost 200 pages. But if you look at the reference manual and you write it out, you can use, for example, raw pointers to write your values directly into the sort of magical memory addresses, and it works. That's how I got my first LED blinking, but it's not particularly pretty, and I definitely wouldn't want to do this for all of the thousands of different registers that you have. Vendors kind of, so like chip vendors know this. It's really painful to program for these, so they came up with something called SVD, which is a system view descriptor file. It's an XML file that describes all of these registers that a chip might have. And then there's tooling for Rust. There's SVD to Rust, which can look at the XML file and generate a crate for you that sort of abstracts over this raw register access. And it looks sort of like this. So you have singletons. You have the peripheral singleton that you can only take ownership of once, and then using the members of that structure, you can modify individual bits in all of the registers, and it sort of makes sure that you don't like typo an address or write a wrong bit pattern to something that doesn't support it. Okay, and packs really help writing code. I mean, this what you see on the bottom is much easier to reason with than actual just raw memory addresses. So with that, I got my first version of this game working. So you can see there's some debug wires running to the board, and it has LEDs on it. It was great. It worked. But we can do even better. So instead of writing, even though it's a bit of a nicer API, we still don't want to manually deal with the hardware. Rust has a great ecosystem for this. There's a crate called Embedded HAL, which provides a lot of very high-level generic traits for controlling, for example, pins or serial buses or other peripherals. Then that sort of lets application or like firmware programmers do not really care what hardware they're writing on. So you can reuse code between different variants of a chip or entirely different chips. They all work together, and it's a safe API. For that, you need what's called like a chip-specific hardware abstraction layer, which implements those traits on top of the peripheral access crate that you just generated. And with that, now the sort of API for setting a pin on looks more like this. So you have, again, you have the peripheral singleton, but now you can turn it into a sort of higher level, strongly typed pin that's configured into, output pin, and then you can safely write different states to it without dealing with any registers or any hardware specific stuff. And once you get that working, here's a little recording of me playing the game. So you press a button, turns on, it gives you 2 random numbers, and then, here you can cycle the LED brightness between 3 levels. And by pressing the different number buttons, you add the other number. So here I was pressing B, and it added A to the B number. And there you go. I just sort of finished it. That was an older firmware. Now, if you sort of beat the game, it flashes the LEDs, lets you know that you won. In this version, it just instantly randomizes the numbers again. Here you can see in A, I have 2, and I'm just adding it to B until B is fully lit. And then because how overflow works, you can sort of add 63, which was in B, into A, and it'll underflow back to, so that all the bits are 1. That's how it works. The actual sort of firmware that ends up running on this after all the packs and hardware abstraction layers is only about 300 lines. The gameplay itself is maybe 20 lines, but the majority of the code is still controlling all of the different LEDs according to what you have in A and B, the brightness controls, making sure that when you press a button, it doesn't register like buggily S2 presses. And majority of the code is actually about power management. So you can see if I don't press anything for a couple of seconds, it goes into sleep mode, which lets this single coin cell last for like weeks or months. It doesn't really use any energy that way. Most of this stuff is abstracted through like the HAL, so it uses the safe interfaces. But some behavior is really hard to describe in a safe manner, in a safe API. For example, the power management, this going to sleep, is really hard to make in a HAL because it has some implications. When you go into sleep, what it does, it pauses your program execution, but it also resets some of the peripherals. So for example, the GPIO stuff, it gets reset between sleep states, so you have to sort of reinitialize it. But that's really hard to sort of express in an API, that suddenly your like well-defined state is now, it could be anything. So you do have to cop out and use the more lower level unsafe register access sometimes, but it's not too bad. I mean, this is a simple firmware, so it's not too hard to like program or keep it in check mentally. And this works. This is a sort of complete, I say it's in production. I gave one of these to my sister and she's been happy with it. So I guess I can say I've released a hardware game. All of this stuff is open source, so including the hardware, it's on Open Source Hardware Lab. You can get the schematics and board files if you want to make some of your own. The firmware, that custom fork of Rust, and all the peripheral and hardware abstraction layers, they're all open source. You can go look at them. They might be a bit ugly, still very much under work, especially the HAL stuff. There's only me and a couple of other guys who've been on like a best effort basis improving the ecosystem, but it's there. It's enough to get started. And if you want to learn more about sort of way more in detail about what it takes to actually patch Rust or generate those access crates or deal with, for example, I didn't talk anything about linking and configuring that sort of stuff. I have a blog post series I wrote this spring while I was working on this game. You can go read it. It's on my site. It's about, I think it takes like 45 minutes to read all the way through. It's pretty good. So yeah, that's this project done. I'm actually pretty happy with it. It ended up being sort of exactly what I expected. And now that I have all of the ecosystem parts done, if I want to make another one, design a different sort of game, it's going to be so much faster. I don't have to do all of this. I mean, I thought this was going to take maybe a week from start to finish. It ended up taking like 4 months, mostly because of all the hardware HAL stuff. So yeah, and now that we have these generic traits, we have the embedded HAL implementation. We get to use very generic drivers. So for example, in this picture, there's one of those OLED screens, and I didn't have to write a single line of code to get that working. Rust's sort of genericness really helps there. If I want to make, for example, I mentioned Tamagotchi earlier, I might do a project like that, and I want to use one of these displays on it. I don't have to write any like driver firmware for the display itself, because you get that for free with Rust ecosystem. So yeah, there's a lot of ways you can take these chips, even though they're very, very small and dinky, 2 kilobytes of memory. They can do it quite a lot, and I'm excited to see what sort of other games I can make. And I definitely learned a lot more than I thought I would making this project. Yeah, and I'm a good 10 minutes over my time. That's everything.
All right, perfect. So yeah, this was super cool. And so I'm very much going down the path of where you seem to be at the beginning of this. And so I'm very happy that like I have your resources now to go and check out when I want to learn how to patch Rust C for whatever hardware I'm doing. But a few things I'm wondering about. And so with the chip that you used, so I'm using like the ESP32s. I've got like a few of them on like the real kind of thing, and then I've got like the dev boards as well. Yeah, it's like so fun having like these like little things that you can just plug into, and most of them run Rust right off the bat. But when it comes to the chip that you used, how constrained did you feel with what you were doing? Like, did you only use part of the available resources, or do you feel like you're really pushing up against the edge of what's available?
Not with this thing. This project, it didn't end up using that much. I think I allocated like, 100 bytes for the stack, and static variables take like another 100 bytes. So I'm using maybe 10% of the 2 kilobytes of RAM, and the firmware was, I think, about 2 kilobytes in total out of the 16K that I have available. But then some other stuff, for example, if you add the driver for this display, now it balloons up and I'm up to like 12K, which is like, that doesn't leave much headroom. There's some things you can do to improve it. For example, this display, it has 8,000 1-bit pixels, so that it takes already 1 kilobyte of memory to store the frame buffer. But you can do some tricks. You can, for example, not store a frame buffer and generate it as you write it out to the display.
Oh, interesting.
You can do some tricks. I don't think Rust specifically adds like any bloat. So it's like the situation is as good as it would be with C or assembly. I didn't find a problem there.
And I guess like a question from that perspective as well, like when I'm doing stuff with higher level embedded Rust, so like I'm doing like, let's say like Linux on a Raspberry Pi or something, and I write out to SPI, I feel like, okay, I have this one function that is talking to the hardware, and now that I have that abstraction, I can use it everywhere, and it feels like I'm writing normal Rust. And so is that sort of what you experienced as well, or was it like, oh yeah, you had to be really low level the whole time?
Oh yeah, absolutely. Especially with, the embedded HAL stuff, that already takes a massive load out of your brain because you now just think in like the logical ways. But you can definitely separate the code out into like a very small shim that actually interfaces with the hardware, and you can use any Rust library really and like write regular Rust.
Yeah. Okay. That's pretty cool.
You do have limitation. For example, you don't have an allocator. If you have a bigger chip, you can add your own allocator. But with 2 kilobytes of RAM, I didn't think allocation is really worth it.
Yeah.
But definitely on an ESP32, I've written Rust code that uses an allocator, and it really looks like regular STD Rust code for the most part.
Yeah. Yeah, absolutely. And so when it comes to I guess like designing and like doing this iteration process, was it really like a sort of a linear process on this one? Like it was like, so here's sort of what I heard when you said that you had to make changes to Rust C, or you had to like do its own version and stuff, is like, to me it would be like that there'd be a whole bunch of walls that you run into and you have to figure out how to overcome, and you have to reach out to a lot of people and find out a lot of things. And so what was that process like?
Oh yeah, it was definitely, yeah. I thought it was going to take a week, 2 months in the end. So a lot of walls, mostly because with the Rust toolchain, I didn't sort of, when I ordered all the parts, I didn't realize it was an E variant of RISC-V. So I didn't know it was going to be a problem. But luckily, there's actually, there's a lot of way smarter people who do this a lot. And they're really helpful in the maker communities. Not very many people use Rust on this thing, but there's quite a few people that use regular C, and just talking to them really helped me with like how to control all the peripherals and what sort of quirks the code generation has and that sort of stuff.
Yeah. Okay. Yeah, this is super cool. So I saw that you have a blog post. I'll make sure to include it in like the notes afterwards. But I'm really excited to take a look through that, because I think the process that I'm going through right now is very similar. And now that I have your resources, it's gonna be a lot easier. And so maybe in the future I will show off my own little project. My brother built this. My brother knows hardware and I don't know hardware as well, and so he like put together this like ESP breadboard kind of thing. And now I'm like, wait, maybe I should write a game on here. Actually, one question we have right here in chat, I guess relative to the discussion on sort of like handling some of these like overcoming some of these things. Is it easier to use Rust or C for that kind of stuff that you were doing? Did you find?
Okay, there's one very big difference, is that all these vendors already provide C libraries and tool chains for you to do this sort of stuff. So you just get to the point with C. Once you have all the tooling in place, I prefer Rust. I like Rust. I like writing Rust. So maybe a project this small that doesn't really have very complex firmware in the first place, Rust doesn't give that much of a benefit. But I can imagine if you're building something bigger, if you're, for example, with an ESP, if you're writing like an IoT application that does Wi-Fi, then you really want that sort of Rust safety guarantees and nicer APIs. But to sort of get started, I think, C might be less friction.
Yeah. and then the question was also reposed from a different angle that I like quite a lot. So even though Rust has benefits, does it make the job harder by abstracting? And so were there times where you felt like you wanted to touch the hardware, but maybe like one of the abstractions that was there prevented you from doing what you felt should be natural?
Not really. Like, yeah, I can see what you mean, but I think with how peripheral access credits are handled, it's always sort of easy to just cop out and use unsafe and poke at the register manually. So you're not stuck with the higher level abstraction. You can always go in there and do it manually.
Mm-hmm.
So
Okay.
I don't think it was like a downside.
Sounds good. Sounds good. Okay, that makes sense. And then the final one here, which I also like. How many boards have you messed up because of bad soldering?
Do I dare to say? Let's see. I think I made 3 boards that I used for like development, and then I made 3 boards that I gave out to people, and out of those I burned probably 2. So not too bad. I have some other boards that use the same chip, not the game boards, but like here's a little one that talks USB.
Here, wait, let's do this. Yeah. Oh wow, that's very small.
Yeah.
Interesting.
And I have these which are just breakouts. So this doesn't even have any hardware on it. It just breaks all the pins out. I burned quite a few of those last ones.
Yeah.
Mostly when doing like power management stuff.
Oh yeah.
Easy. But for the most part, these chips are surprisingly resilient. They definitely over exceed their sort of specification or what you would expect for a 10-cent part.
Okay, yeah, that's pretty nifty. My current goal is to basically make the exact same thing. So like design a PCB that's the exact same thing as like a development board, but it gets rid of all the fancy pins and stuff, and instead just has a whole bunch of lights that you can address. So seeing yours is like a pretty cool way to do that. And I also didn't. You mentioned a technique with being able to use one pin for multiple or a few pins for multiple lights. So I'll have to look into that. I think the Charlie is something.
Yeah, Charlie plexing. I presume invented by someone named Charlie. But yeah, it makes. Can I show? I have easy EDA open here. It doesn't generate very pretty schematics, but how do I get this open? I have. Let's see, slides, and then where is? Here you go. So here's the sort of schematic for that board.
Pretty really? This is it?
Yeah, here's the chip up here, and then you have the battery is over here. 2 buttons, and then here's the like Charlie plexing circuitry. So it's only using.
So you got a lot of D2s going to stuff. Oh.
So there's only 4 different pins going in, but depending on how you orient the LEDs, you can sort of trick it into driving more than just 4. It looks like this.
Okay. Oh, so cool.
Yeah.
Awesome. Oh yeah. Okay. So this is like the
the board file.
Huh. Yeah. Nice. Okay. Awesome. So we have a few more questions in the chat, but I'll let you answer them in the Rust Gamedev Discord. And so yeah, I think there's be quite a lot of interest around some of the files and stuff. So I'll make sure that all the links are available because I think it'd be pretty cool to check out. So yeah, thank you so much, Noxon, for going through that. I really like how we're like touching stuff that's like, it is game dev, but it's not like the classical game dev that we think of necessarily. And so it's very fun. Perfect. All right. And we will be back in just a minute to learn about Tonnet. All right, so we are back with Puzzled Squid, who's going to talk to us about the game they're working on, Tonnet. I'll hand it over to you.
Okay, thanks a lot for the invitation. Yeah, can you see my sharing? Yeah, I think you can. Yeah, so hi everyone. So my name is Pierre, and but I go on the internet I go by Puzzled Squid, and so just to give a little bit of background before I jump into the topic. So my background is like typically like firmware development, low-level programming, hardware design, right? So that's typically what I do. But I was kind of looking for like a side project to do, right? And especially like something which was using Rust. And that's why I'm here today to talk about Tonnet, like my side project, which is a very small game, and it's about computer networks and tunnels, right? It sounds a little bit weird. Yeah, that's because it is weird. And so just in this presentation, I just have like literally I just have 2 slides just to introduce the project a little bit, just to explain what it is. And then I think I would just jump to the demo and see what the game looks like. And yeah, and we take it from there. So what is Tonnet? Yeah, so I said, so it's fully developed in Rust. Like I would say 100% of it is written in Rust. Actually, no, it's not fully true because there is a shader code which is still using like a WGSL. But besides the shaders, like everything is written in Rust, and it's using the Bevy engine for that. And so the reason of why I decided to go with Rust with this project is simply because I was kind of used to Rust already. I used it in the past, like for some of my projects, which were absolutely like nothing. They were absolutely nothing to do with game development, right? Like I was working like on low-level stuff and small tools and things like that, right? So I was already kind of familiar with the Rust language. I don't pretend to be a really expert in that, right? But I just got used to it, right? Like the language, the infrastructure, the ecosystem, the tool chain, which I think is it's really good, right? And so I was looking for a side project, and I also had like this idea of a game that I had like in the back of my mind for like some time, and I said, yeah, why not trying to implement it with Rust, just for fun, right? I didn't really want to use any like big engines like I don't know, like just to name a few, like Unity, Unreal, and so on, right? Simply because that wasn't really the scope, right? I was just trying to have like to find like a fun project to have in Rust, right? And just have fun from there. And so I started. I think I started the project like 2 years ago, almost 2 years ago, and at the time, like the Bevy engine started to get some traction. I was already familiar with Rust at the time, right? But like the Bevy engine started to become like really usable, and I was like Bevy has all this concept of ECS and so on, right? So I was a little bit curious, and I just wanted to give it a go, and yeah, I kept using it, and here we are. So yeah, talking a little bit more about the game. So it's I mean, I'm the only one working on that, right? It's a solo project. It's just something that I do like as a side project. So it's still it's a fairly small game. Don't expect something big, right? And I was trying to make like kind of like a mix between a lot of different genres. Like namely, like here I'm just saying like a puzzle. It's a mix between puzzle, exploration. I also mentioning like incremental games, but it's also taking like some inspirations from like walking simulators and other games, right? And so just to explain what the game is about, it's so you just wake up as a network technician, right? And you wake up as like in an underground facility where you have like all these different bunkers, and like each one of them has its own like computer, right? Which we call like endpoints in the game. And so the goal of the game is simply like to build a network to connect all these endpoints together, like in the most efficient way, right? So that's why. So I'm calling it like a puzzle game because that's really the goal of the game, right? Just designing like the like a proper computer network. But there's a little bit more to that. Like I said, it's also about exploration because you can just you can also explore the facility. I mean, I'm going to show in a moment in the demo, right? But basically, like there's a backstory. You can explore like the all the different bunkers. You can meet people and have dialogues and things like that. So it's a little bit more than just a puzzle. And I'm saying it's an incremental game mainly because it's an open world also. So there are a lot of puzzle games which are like, you have like level 1, we give you a problem to solve, then you solve it, and then you move on to the next level, and so on, right? But I didn't want to do something like that, right? So I really wanted to have like an open world, right? And when you start a game, you're going to stay in this in only one level, right? And so in this level, you're going to have like a lot of different endpoints, and then it's up to you to connect the endpoints that you want, right? And to design the network that you want to build. And then, so depending on the performance of your network, right, depending on your design and how you organize your network, so it's going to be more or less performant and or efficient. And based on that, you're going to get some credits, right, and some points. That's why I'm saying it's an incremental game, right? Because you're going to start like earning like more credits, which you can then earn, like which you can then spend on upgrades and things like that, right? But it's not like an idle game, right? So you are not, well, normally you shouldn't have to just wait on your screen and wait for the game to just play on its own, right? So the goal is always to be like active and to expand the network, right? So so I guess that's one difference from like a normal incremental game somehow. What else can I say? Yeah, so there's a demo available on Steam and on itch.io if you want to try it on your own. And it's coming December 1st. So the full version is coming December 1st. One thing I wanted to tell you also, like before moving to a demo, is like it's not really like an educational game. Like it was actually something I was thinking about, like when I started the project. Is the original idea was, oh, that would be nice to have like kind of a simulator, like a network simulator, which simulates like a full IP stack, and I don't know, you could like implement BGP or things like that, right? Like actual network protocols, right? That was actually the original idea. But I changed directions a little bit because what I realized, it was first a little bit too complex sometimes. I mean, that sounded fun, right? But then I thought like, yeah, it's still a game, so let's try to keep it simple. And so that's why. So all the things that you're gonna see in this game is like, it's not really applicable in real life, right? That's what I meant, right? So all the protocols which have been implemented in this game are completely fictional, right? I just designed it from scratch just for the purpose of this game. And the other thing I wanted to say also, yeah, it's not really like a resource management game, not like Factorio or Minecraft or all these type of games, right, where you have to manage resources. Here, so basically the only resource that you have is just the credits that you earn based on the performance of your network. So like it's really like a puzzle game, right? The goal is really like to build a network, right? Not necessarily to manage resources or things like that. So don't expect the next Factorio or Satisfactory or anything, right? Although I took like some inspirations from these games. All right, so I think let's move on to a demo, because that's, I think, the only side that I have. Please feel free to interrupt me, right, during the demo. I really don't mind. In case there are some questions. Okay, so I have an early build of a game, and I think so. What I'm going to do, I'm going to load like a very specific save, which I think I took like halfway through the game, or a little bit before. So let's see. So just to explain the concept a little bit. So that's how the game looks like, by the way. Very basic. So you see it's using like a pixel art, right? I didn't try to go with something like too realistic. And so the way it works, so it's a first person, right? And so from there you can like, you just have like a couple of basic building blocks, right, that you can use to build your network. I don't know how it looks in the video. It looks a little bit dark, so let me just pick the light here so that you can see a little bit better. Yeah, I guess it looks a little bit better. And so the way it works is, you see, so you have all these different basic building blocks, right, that you can use to build your network. So for instance, here you have a relay, and you see like automatically it will connect to the closest device, right? So that's typically what you would use like to just make wires, right? And then you have like different different devices like the hub here, which allows you to connect several wires to it, right? And then you have like some more advanced devices like a filter, which can be used like to like control the data flow a little bit better. And I think this is where the complexity of the game comes from, right? So it's really like depending on how you define your filtering rules and how you define like and how you connect your different wires, like the performance of your network is going to depend on that, right? So that's why. So I'm just showing that as an example. But that's so what I'm showing here is it's really the basics, right? Now I want to show like more the interesting part. So let me show the map here. As you see here, it's like the map of my current save. Things are kind of procedurally generated, not fully, right? It's basically the locations of the different bunkers, which are kind of random. But as I said, so there's kind of there's a storyline, right? So the important interest points, right, are not randomized, right? It's only like the different bunkers, which you can see here, right? Oh, so this is where I am, right? And you see in blue, this is where I put the wires, right? So here it's like, yeah, I would say I play like an hour or two, right, to get this network. And what I would like to show here is like the typical type of puzzles you would get like once you reach this point. So here you see like I'm getting inside this this endpoint where I can find like this little guy here. I can talk to this guy, and you know there is a backstory and so on, right? So I'm not going to go into too much details for now. But long story short, so when you start talking to the guy, he's trying to tell you, oh, he's doing like some research, and he's telling you that he's doing some search queries, right? And so the things you can see is that if you connect like a device to this endpoint, you can see some packets, right, emitted by this endpoint, which are going to be like the search queries that I was referring to. Yeah, you see. So if I just over the network, I can see like the details. I can see like the subject, so what the packet is about. So it's a search query coming from the guy, and I have a source and a destination, right? They kind of look like IP addresses, but they are not. But they're kind of similar. And so you see, so the source address is actually so this guy, obviously, right? And here you see the destination is 0.1.2.0. Okay. And so the goal of the game here in that case is you are supposed to explore a little bit, right? So the game is not going to tell you exactly where all the different endpoints are. So you are supposed to explore a little bit. And that's what I did before. And you see on the map here, I put some annotations on all the bunkers that I explored. So for instance, here I have this guy here, and here I took some annotations. Here I can type here. And here I took like some notes about the address, right, of this endpoint. And so here, if I go back here, let me see if I can find the packet again. Yeah, it goes to 0.1.2.0, right? And so, well, I know that it's coming from this one, right? 0.1.2.3, but that's because earlier in the game, right, I found this endpoint, and then I took some notes about the address. So this bunker is a server room, so we're going to go there, and I'm going to show you how we're going to connect the two endpoints together. If there's already a network, there's already a wire here, it's because this endpoint is already connected to an already existing network. Just to explain a little bit how it works, right? In the game, you're going to have some mainframes, which are going to send like packets to a lot of different endpoints, right? So your main network is going to be it's going to help like the networks, like to the mainframes to talk to all the different endpoints. So that's why you see like all these blue wires coming from here, right? But you can also have like some peer-to-peer communications, like you see these two endpoints that I was referring to, right? So this one and the server room, they are talking to each other, right? So you have several ways to solve this puzzle, let's say. But like the thing I'm going to do here is just I'm going to replace this filter, because I just put this filter here just to prevent this endpoint to send like too many packets to the main network, because I know that these packets were not properly routed, right? So what I'm going to do here is just I'm going to create a different path specifically for the packets emitted by this robot. And so if I run it now, let me see. Configuration goes here and here. So now if I have a packet coming here, So instead of going to that direction, it's going to go here, right? And then from here, I can just like connect it, like create like a different network, which goes directly to a server room. So here, yeah, I'm just connected here, and then it goes here. So just before the demo, I created the tunnel and I created the and I connected like the wires already, so we don't have to do it during the demo. But that's typically the thing you can do during the game. So I'm just gonna follow the wire for now and see if we can find it. Yeah, and you see when you start exploring, you're gonna have like some dialogues and stuff just happening. Go. I hope it's not too dark for video. It looks okay on my monitor, right? But sometimes the video compression is not so good. So I'm just gonna follow the wire. And here we go. So you see here I have like so I have a lot of devices and a lot of features, mainly because so the mainframe that I was referring to before, so you know the one which is sending like a lot of packets, it's located here. It's located here, right? So which is it's supposed to represent like a military base, right? So and the military base is like sending a lot of packets, and so basically, if I want to route the packets to the right endpoints, I had to create like all these different hubs and filters just to make sure that the packets are sent to the right location. So that's why you see all this mess here. But like the wire I was referring to before, that I was following, I think it goes here, here, and then it goes here, here, and here we go. And here we're in the server room. And here we found like the proper endpoint, like the 0, 0.1, 0.2, 0.0. But so the problem is it's already connected to another network. So I'm going to do as I did before. I'm just going to remove this guy. Actually, no, let me put it back. I'm going to remove this one here, and I'm going to replace it with a hub, as I did before. And so let me connect it back here. So that's the network which was connected before. And here I have another port which is open here, which I can connect here, which is the wire that we were following. And so now let's see if we see the packets coming. So here we go. So here we see the search query, which goes here, and then it goes to 0, and then it goes here. And here we go. And here we get some points because we managed to properly transmit the packet. And now there's another problem that I want to show you, because now if we do send packets to this, to this server, it's going to respond, right, with a search result. And the problem with the current circuit that I have is that it's going to go back to the wrong direction. Like you see the search result is going to the wrong direction, right? And so the way to handle this situation is simply to use filters. So that's what I'm going to do here, this special device here, which you can configure. And here you have like a bunch of options. So you can think about it as like when you configure a firewall or router or something, right? So you basically have rules and about like what you want to do with a packet. And so here in that case, I can configure like which port I want to filter. I can specify if I want to filter based on the destination or the source of a packet. So in that case, that doesn't really matter. The operation, like basically the operation that I want to do between the address and the mask here, which I can control. Okay, so in that case, I'm just going to leave it as a star just to match all the addresses. Because basically what I want here is I don't want the packet to go in that direction. So I want to configure the filter so that it sends back the packet to the other direction. So let me see. So here I'm just going to match. Okay, so if the address matches the star, right, which is a wildcard, so okay, everything is going to match basically, and the action is going to be sent back. Okay, and so now if we have another packet coming, here we go. So we have our search result. Whoops. Another search result. Wait. Oh, I was not filtering the right port, right? So you see the port is number 1, right? And I was filtering the number 0. So here I just need to change it to 1. Okay. That explains it. And here we go. And here you see it went back here. And now if I do like single step, now it goes to the other direction. And now eventually it will reach the endpoint that I was showing you before, right at the beginning of a demo, and I will get some extra point for that because now the packet is properly routed, and I have this peer-to-peer connection between the server room and the endpoint. Yeah, so that's pretty much what I have to show today. So here it's pretty early in the game. And no, I said we are almost halfway through the game. I can try to load like one which is a little bit more advanced. Let me see. Go to title. Let's open this one, I believe. Yeah, it's taking some time to load.
So I will mention there are definitely quite a few questions that I can go over. A lot of interest. I think one of my favorite comments here is like, "Whoa, this looks like a real game, TM." It's very, very well polished.
Oh, that's kind.
So one question is Tonnet using Bevy's render, and if so, what is your experience with it?
Yeah, so I'm using the default rendering. It's just so I modified it a little bit because like the way it works in Bevy is you have like this this rendering graph, but you can modify it, right? So I just changed it a little bit to add some post-processing effect. I'm not saying that my post-processing effects are really good, right? It's just because I wanted to make the game look kind of unique, right? But I'm using the PBR, I'm using the Bloom. For the SSO, I know that Bevy does have SSO implemented now, but I'm not using it. I implemented like a very naive implementation of the SSO, and I kind of got used to it. It has a lot of artifacts. It looks terrible. Like I don't think you can see it in the with video compression, right? But I can tell you, like if I go close to my monitor, I can see like all the different artifacts of the SSO. So,
Yeah.
but I don't know. If it looks okay, and I got used to it, right? So that's why I'm okay with it. No, and I'm really glad like I was able to modify the graph that easily, right? I just like for my application code, right? You can easily like just instantiate like a new graph, totally new graph, and just reuse the nodes from Bevy and just do like kind of Lego bricks, right? And you just assemble them together, and then magically you have your new rendering pipeline. So yeah, overall
Yeah,
pretty good. Yeah.
I think from my perspective, like when I first saw images of Tonnet, I very much thought like whatever like the aesthetic was going on, like I really like how everything is very lo-fi in a way where like or you have polygons that represent a lot. Everything is like lower pixels and everything. And just the
Yeah.
like when I first saw it, I'm like I think I saw that and then I saw the word beside it like networking or something that I'm like, oh, I play Factorio. Like even if it's not like Factorio, I love this idea, and so I was sold right away. But yeah, I think the graphics work out quite nice. And I mean, even with artifacting, like as a player who doesn't know everything about the graphics world,
Right.
I think everything just looks very cool. And so you might be like, oh yes, my implementation was not up to par, but from my
Yeah.
perspective, it's pretty cool.
Oh, thanks a lot. It took me a while, like to even like draw everything because I did like everything on my own, right? I was not reusing any assets or anything. Like all the 3D models and stuff, I did it manually, which takes a while, right? And it was kind of a first time for me, like doing like 3D modeling, pixel art and stuff, right? So I kind of had to learn on the fly. So it
Mhm.
might not be the best, like, but it does the job, right? So
Yeah, yeah. And I think just on this point, we have a question in chat. So what tools did you use other than like Bevy and Rust? And so what was it? What was part of like the asset pipeline?
yeah, I mean, I was using Blender, of course, for all the 3D modeling, but you see, like the models are very simple. Like here, it's just a cube, basically. Like this guy here. It's still like everything is made in Blender. For textures, I'm using Sprite, which is really good for pixel art. Uh,
Mhm.
what else? Oh, the audio also. I did well. I did reuse like some from the internet, but like I mean some samples from the internet, right? But like all the soundtracks and stuff, it's something that I did on my own. I'm using like LMMS on Linux, which is pretty good. It's just a DAW, and you just have MIDI and you can put whatever samples you want. And all the soundtrack has been made with that. And I think besides that, that's pretty much it, right? So Bevy doesn't have any editor. Also, so I did like all the levels and stuff. I did it like by I was using like text file to add code like
Mhm.
like the location of all the different objects here, all the different assets here. Like I was manually specifying the
Yeah.
location in the on my text file. It's not ideal, but it's I mean it's kind of okay, right? Because most of the world is still procedurally generated.
Hmm.
Right, so I was not designing like complete levels or things like that, right? Which, I mean, if you start doing that, you definitely need a level editor. But I don't think Bevy is there yet, but I was okay with that, right? So
Yeah, and I was kind of curious. So you mentioned like the text file. What was it? Something that you could hot reload, and so you'd make a change in the text
yeah,
file, and then it would come in.
yeah. I mean, there is like the asset subsystem in Bevy, so you can have like kind of a watcher, right? So meaning like you can modify this text file, and then automatically like Bevy will load it. Yeah. I kept using it all the time, but like not only for the text file, I use it like for 3D models, for the textures, for the sound effects, everything.
Hmm. Okay. Um, Another question. So I think when it comes to like a full large game with everything, like all the systems implemented, that it definitely requires a ton of code. And so someone was
Yeah.
curious, like, what does the compilation time look like for the game?
It's pretty bad. No, it's not too bad. So when it's incremental, it's okay. It's mainly linking, which is a bit annoying.
Uh-huh.
Um, but like if you start like if you compile like a project from scratch, like you have you just clone the Git repository and you just do like a cargo run, right? I don't know. It takes like 5 minutes, something like that.
Hmm. Yeah, that's all pretty good. But I know definitely like if you can't like hot reloading, you have to do stuff like consistently to figure out what you need to do. Then iteration can add up quite a lot.
Yeah. But as I said, so most of the time I spend like during the linking phase, right? The
Yeah,
compilation is
exactly.
still okay, right? But the problem is like I'm starting to have like a lot of different modules, and so yeah, that's why it's taking so much time.
Hmm. So another question. So you mentioned that's not like fully educational, but at the same time, I still see like a lot of parallels between what
Yeah.
you're doing with networks and like a notion, abstracted notion of packets and how they're moving around and how they're passing data around.
Right.
And so one question from chat is how close is like the logic to like actual like IP ideas? And then do you, for example, use STD.NET IPv4 address types for game logic?
I mean, yeah. So yeah, I need to show you an example here because so it's they look like IP addresses, but they're not actual IP addresses, right?
Hmm.
But the concepts are still very similar, like in a sense that, for instance, like if you know about ring networks, for instance, right? There's one of the first puzzle in the game is to design a ring network, right?
Mm.
It's not technically really used anymore nowadays, right? But like if you open like a book about networking, right? That's usually like one of the first topology they tell you about, right? So I kind of reuse like the high level concepts,
Hmm.
but it's not implementing like an actual protocol, right? Let me think if there are like any. There's no concept of some networking per se, like as we have in IP. The only concept that I have here is like you can filter, but like based on the address element, right? So for instance, when you define like the rule, you're gonna have to apply the rule. You can apply the rule on only one element of the address, right? And then
Yeah.
based on that, you can start building like what we can call subnetworks somehow.
Hmm.
I mean, I don't like using the term because it's still very different from like subnetworks you have in
Yeah.
typical IP stack, right? But that the
Hmm.
concept is kind of similar.
Hmm. Yeah. And I mean, like when it comes to, so I mean, one of my favorite genre, or I guess producers of educational games would be like Zachtronics, and the way they approach a lot of it is like
Yeah.
it's not directly, it's not in space chem, you're not doing chemistry, but there are still ideas of like binding atoms together and doing stuff, or in Shenzhen, there's some ideas of hardware, and so.
Yeah. I should definitely mention Zachtronics because that has been, of course, like a huge inspiration for this game.
Hmm.
Uh, in the sense that like you have this puzzle, right? But you don't have like one solution to solve it, right? That's what I
Yeah.
tried to explain at the beginning of the talk. Is like I'm just giving you this set of endpoints, right? And then it's up to you to just build whatever network you want. And I think there's kind of this same notion in the Zachtronic games, right? They
Hmm.
usually throw like a problem at you, right? And you have several ways to solve it, but your solution might not be as efficient as as other people's solutions.
Yeah.
Um, but I guess one of the differences, like in the Zachtronic game, you still have like the problem of having, if I take Space Game for instance, right? You still have
Mhm.
different different problems to solve, right? You have level 1, level 2, and so on, right? In that
Yeah.
case, it's really like it's an open world. Like if I open the map here, and you are free to do whatever you want, right? So if you don't even want to solve all the puzzles and just go for the story, right, and just explore and just have some fun here, you totally can, right? It's just like you're not gonna earn like as much credit, right? And so in my case, it might be a little bit you won't get the upgrades and all the good stuff, right? But yeah.
Okay. Yeah, that's super cool. And so I think that mostly answers all the other questions. Is there anything else you want to show off before we wrap up?
No. I mean, thanks a lot for the invitation and for having me. I'm really glad to show you this demo.
Yeah, and I mean, I think I saw on one of your slides it mentioned that you're looking at a December 1st release date.
Absolutely, yeah. So if you want to try it at home, you can already try the demo on Steam or on itch.io. And if you have any feedbacks, I mean, of course, yeah, just let me know. I'm currently trying to polish the game for the release. I think the game is feature complete at this point. I'm just, releasing a game is a lot of work, right? Just making sure that it doesn't crash, like fixing bugs and things like that. So I'm mainly focusing on that at this point, right? And but yeah.
Yeah, that's awesome. I'm super excited to pick this up when it launches, and I'll chat with you about if we can like check out some other stuff in the future. I think it'd be really cool to hear about like how the launch goes afterwards. And so it'd be great to have you back on again. But yeah, thank you so much for coming out and talking with this. I think with Tonnet, like I've seen a little bit of it, but this was super cool to go through the whole thing.
Thanks a lot.
Yeah.
Thanks for having me. Perfect.
All right. So that is it for this month's Rust Gamedev Meetup. We'll be back next month, of course, like the second Saturday of the month, as always. And I mean, we always love seeing new people come show stuff off. And so if you've been working on something and you'd like to see, or like if you like to just present it, talk about it a little bit, then do feel free to reach out. We would love to have you. So without further ado, we'll end it off for today. See you next month.